Hi everyone, welcome to my YouTube channel. In this video, I'm going to present to you my recent project that I worked on. It's called the PiCar. This is how the car looks like, and as you can see, my phone is next to it, which is what it'll hook up to, and it'll be the controller basically controlling it using the gyroscope that's built inside the phone, but through a web browser. That's going to be the coolest part. But this is how the car looks like, and I'm going to go about the internals of what's in there, so you guys have a bit of clue of what I kind of worked on. It has a Raspberry Pi controller in there, inside down here. I packed it all up. I don't want to reopen it. The board on top is the L298N H-bridge board, where the pulse width modulation pins and the direction and the speed pins are going in there. I'll go over the details of the project in a presentation form, and I'll see you in a bit. The reason why I call it the PiCar is because it is based on Raspberry Pi. So, in other words, it's a web-based, web browser-based Wi-Fi remote control car using the Raspberry Pi. Designed by, of course, myself, Amrit Paul Singh. The hardware that I used for, making this project is an RC card that I bought from Amazon. Took it apart and put in a Raspberry Pi 0W. It's the smallest Wi-Fi based Raspberry Pi currently available. And then I used a LiPo battery, rechargeable, 11.1 volts, and 2200 mAh milliamp hour. Okay, so I used L298N motor drive controller board. It's dual H bridge. For 2 days it allows you to control up to 2 DC motors. And last but least, I'm using my cell phone, and I'm using the gyroscope sensor via web browser. So using JavaScript, you can access the alpha, beta, and the gamma of the gyroscope sensor of the iPhone, and basically I'm taking that information and sending it across over the network, and I'm using that to make a decision on which direction my car will move and how fast it will go. So for some of the software technology that I used is, for the front end, I used, of course, HTML and JavaScript. It's web-based project. So you can access the website with the URL link, and I use JavaScript and some simple jQuery script to transmit real-time gyroscope data from website to Node program. So for the backend, I used Node.Js, and specifically I used the socket.io package. I'm sending data in real time from my website to the Node program, where the socket connection is kept open, and the data is sent across as values of the gyroscope X, Y, Z. The alpha, beta, and gamma are changing. So in another thing is I use C++ along with Node.js. I wanted to control the pins using C++ because C++ is really close to hardware. However, to bring in the data from Node program into C++, I designed Linux inter-process communication between the C++ program and the Node program. Those two application processes were running at the same time, but they are able to talk to each other. In the C++ program, I declare my pins for the forward, reverse, and forward, reverse pulse width modulation, and left, right, and left, right pulse width modulation. So, in other words, this is how it looks like. You have the Raspberry Pi, and you have a battery. Battery actually is a different battery that I'm using, but I couldn't find an icon for that within Fritzing software. But basically, using L298N H-bridge, 2 of the pins are here for the pulse width modulation for the 2 motors, along with which direction the motor will spin. And one of the motor is for steering wheel, for which direction the car will move into, and the second motor is for going backward and reverse and forward, basically. So this is like the overall design of the whole system. I have Raspberry Pi. which has Wi-Fi output communication to any device that needs to connect to it. And within Raspberry Pi, I have Raspbian operating system running, and I created two applications, one Node program and one C++ program. They were able to talk to each other. However, when you're on your phone, if you're connected to the Raspberry Pi, then you can access the Node web server that I created. You could access it through a web page, basically, and simply anybody who's connected to the Raspberry Pi can access its IP address, and data can be transmitted and received via the web browser, okay, on your iPhone. Last but least, I'm going to demonstrate to you my project, and I hope you enjoy how it works. Alright, this is the phone and this is the car. We're going to be controlling the car using the phone. And right now I came on my phone and I turned on my personal hotspot, the Raspberry Pi hooked onto it. And now I'm fully connected to it. At this point in time, I can go to the web browser and I can go to the IP address of the Raspberry Pi, and I should be able to see the controls to control the car. See, I'm going to hit refresh, and this is one of the local IP addresses within the network, and this is the IP address of the Raspberry Pi that I have over here. As you can see, as I apply gas, so basic controls that I'm going to explain to you guys right now. I have the gas option, which is controlled by the gyroscope, basically, right? I give it gas, then the car moves upwards or backwards. But to change the direction, I have a reverse button here, which when I click on it, the car will start going reverse mode. Okay, so right now it should move forward according to my theory, and it is as I'm applying gas. You can see I'm using the gyroscope values, which is applying pulse width modulation, duty cycle, to the percentage as it's showing over here. So I'm going to do reverse again one more time. You can see the car is moving backwards, and now I'm gonna try to make a right turn on forward mode. You see, it went that way. Now I'm gonna try to come backwards, leftwards. Okay, all right. I'm gonna move forward now one more time. It hit the wall, but the point is that the controls are working pretty nicely right now. And that'll be the end of my presentation. Thank you very much for watching this video. Peace.